We can create two types of replications, unidirectional and bidirectional. Unidirectional means active standby cluster setup. One cluster is active, one cluster will be standby. Bidirectional means active. We can write into multiple active clusters. Unidirectional, it's basically used for disaster recovery purpose. In case if something goes wrong to the active cluster, we have standby or replica cluster to fix the things. This is where we usually set up unidirectional replication, development, testing copies, connectors, integrate to custom consumer. Bidirectional replication will be having multiple active masters. We can also use it for disaster recovery or data center locality. In case if the application is taking traffic from multiple regions or multiple data centers, we can route the traffic to the nearest data center. XDCR keynote. XDCR only replicates data. It does not replicate views or indexes as of version 6.5 or as of this recording. To replicate views or indexes, you have to take backup of the index or view definitions and you have to manually create it. Although conflict resolution rules are in place, try to avoid updating the same document in multiple clusters with bidirectional XDCR. Best practices. Keep users or transactions isolated to a DC and only redirect to another DC in case of any major outage. To create the XDCR, cluster sizes don't have to match. For example, if you have 10 nodes in your source cluster and 3 nodes in your target cluster, you can still create XDCR between them. Both data encrypted and non-encrypted replication cannot occur between the same XDCR source and destination cluster. And flushes also not replicated. How to handle conflicts in bidirectional replication? If the same key is updated in both clusters, which one it should consider? Whether the document that has updated in the source cluster or the document that has updated in the target cluster. That will be decided by the conflict resolution policy. It's fully automated process. No manual intervention is required. Conflict resolution policy is configured on a per bucket basis at the time of bucket creation. It cannot be changed later. If you want to change the conflict resolution for a bucket once it is created, you have to drop and recreate it. XDCR replications cannot be created between the buckets with different conflict resolution policies. For example, if you have conflict resolution type as timestamp for your dev bucket and your stage bucket is having conflict resolution type as sequence number, you cannot configure replication between these two buckets. So they must be configured with same conflict resolution policy. These keynotes applicable till Couchbase version 6.5. These may change in future versions. Conflict resolution types. Sequence number based conflict resolution. Sequence numbers are maintained per document and are incremented on every document update. The sequence numbers of source and target documents are compared and the document with higher sequence number prevails. For example, the document in my dev cluster is having sequence number 3 and the document in my test cluster is having sequence number 5. The document with sequence number 5 wins. Based on timestamp. Timestamp based conflict resolution, often referred to as last write wins. It uses the document timestamp to resolve the conflicts. The document whose update has the most recent timestamp wins. In case if both documents have same sequence number in source and target clusters, additional metadata values will be compared like CAS value, TTL. Same applicable for the timestamp based conflict resolution as well. If both document versions have same timestamp value, sequence number, TTL will be compared. If you are creating XDCR for the first time in your cluster, it is a two-step process. First, you have to add remote cluster and then you have to create the replication for your desired bucket. These are the required fields when you are adding a remote cluster. Cluster name, a logical name for the remote cluster, which is easy to identify. It's the name of the remote cluster, which will help us to identify to which cluster the replication is going. And IP address, you can provide any one of the cluster node IPs. Username and password to create the XDCR. You can use admin credentials here or you can create a dedicated user with XDCR role and use it here. Half SSL and full SSL. Half means encrypting the password only and not the data. For full SSL, we need remote clusters root certificate and client certificate and client key. If you don't have client certificate and client key, you can also use username and password along with root certificate of target cluster. These are the commands to add remote cluster using CLI and REST API. This is the second step I was mentioning, creating replication. You have to select source bucket from this drop down and here you can select the remote cluster. Here you have to provide remote cluster bucket name and the priority of replication. Filter expression. If you don't want to copy all the documents to the target cluster, you can provide a filter condition so that it will only copy the documents based on that filter condition. It's always a good practice to enter a document ID to test whether the condition is true or false. These are the checkboxes for filtering delete operations or document expirations. These are the commands to add replication using CLI and REST API commands. Filtering expressions, pattern matching examples. For example, if I want to copy documents that has country as India, I can mention this, so on and so forth. These are the other filtering expressions. XDCR additional use cases. the fastest way to upgrade because no rebalance is required. For example, I have a cluster with multiple nodes where we hardly get the downtime. It's a little bit challenging to upgrade the Couchbase version on that cluster because we need to perform rebalance couple of times when we are adding new nodes and removing old nodes. Of course, we can use swap rebalance technique, but that will also use some resources in terms of CPU and RAM. So what I will be doing with XDCR, first I will create an empty cluster with desired number of nodes with the higher version of Couchbase. I will create all the buckets and then I will create XDCR from old cluster to updated version cluster. So it will be very fast without any rebalance. It will take some time depending on the data size. Once both old and the new cluster are in sync, we will route the traffic to the new cluster. So simple to set up, easy to roll back in case of any issues. There are few cons. It requires extra nodes for the new cluster because this approach well suited for cloud hosted clusters just like Google Cloud servers or AWS servers. Might be difficult for on-premise setups, and this approach also requires a very short downtime for changing the application's connection settings to the new cluster with higher version. Copying data. Use XDCR to copy data between buckets on a local or remote clusters. Use XDCR to copy data between dev, QA, staging, prod environments. This is the fastest way. Otherwise, we need to take dump from the source cluster and we need to transfer the dump to the target cluster and we need to restore the dump. Instead of doing all this, we can simply create a replication from source to the target cluster. Use Flush XDCR as an alternative for bucket backup restore activity. This we already discussed. Suppose if we got a backup restore request for a bucket, instead of taking backup dump, restoring it in the target environment, you can flush the bucket in the target environment and create an XDCR from source to the target. Why we need to choose that? Because that is the fastest way to copy the data. And you can also use advanced filtering for selective data copying. XDCR consumes CPU resources. After you are done with copying, delete the replication. In case if it is needed in the future, you can again create the replication. Monitor XDCR. We can see this in the demo section. Thanks for your time. See you in the next lecture.